Good afternoon, class. Sorry I couldn't be with you today. I'm not feeling that great. Hopefully I'll be feeling better tomorrow. I want to go over first sort of a recap of fundamental counting principle. Fundamental counting principle. Oh, geez, my penmanship is atrocious. Okay, oh man. Okay, fundamental counting principle. Sorry. Okay, so fundamental counting principle basically can be summed up as the following. Total outcomes equals outcomes of event 1 times outcomes of event 2 times outcomes of event 3 and so on. Okay, so again, E1, E2, E3, these all represent number of outcomes in the event. Number of outcomes in event. Number of outcomes in each event. Okay. Okay, examples from our quiz yesterday, where we had player 1 picking a character. So that could have been event 1. Event 1 was player 1 picking a character, and there were 44 possible to choose from. Event 2 was player 2 picking a character. Now we had two cases. One was player 2 could pick the same character, in which case there were 44 outcomes. Okay, and this is, and then just add them up, or multiply them, 1,936, I think. Okay, whatever happens to be. The one thing that I think I might have failed to mention was what's my definition of an event. An event is very broad in this sense, very, very broad category. It can mean anything. Basically, an event is something with multiple outcomes. Any event that I talk about in this context is just something with multiple outcomes. Okay. Now, what happens though if we have an event, but some of the outcomes are identical? Okay. So as an example, okay. Number of ways to arrange. So calculate the number of ways to arrange the following combination of letters. P, O, O, L. Okay. Well, I'll list a few. First, there's P, O, and I'm going to write the other O in a different color. Okay, L. Then we could arrange it as P, O, well, green O, then black O, and then L. Okay, these are actually different. We count them differently if we use fundamental counting principle. Each of these is actually a separate outcome, even though they're identical. Okay, so identical outcomes. Okay, we're basically counting the same outcome twice. Okay, let's continue. I can go P, L, O, O, or I could go P, L, O, O. Oh look, we've got, again, another identical outcome. Okay, and this will actually repeat for basically every combination. So basically, if I can write the combination of letters down one way, I have an identical way I can write it just by swapping the two parts which are the same. Okay, so this is the following. If they were all unique, then I would have the following number of ways to arrange things if they were unique. Okay, if they were unique, I would have 4 ways to pick the first letter. I would have 3 ways to pick the second letter. I would have 2 ways to pick the fourth letter and 1 way to pick the last. Or in other words, this would be 4 ways to times 3 times 2 times 1, or 24 ways. However, for every outcome I get, another outcome is actually perfectly identical. So I have to divide this by 2, but not just 2, it'll be 2 factorial. Okay. Now it doesn't make much sense actually for 2 to be 2 factorial, so I'm going to give you guys another example. Okay, and I'll just finish this. This will be just 12. There's 2 factorials is 2 times 1. Now I'll give you another example. Okay, so number of ways to arrange ba. Okay. This one I'll actually write out all of them. This might be a while. Okay, but I'm going to write out all of them. So the first one will be B. There will actually be quite a few number of combinations. Okay. Alright. So there's 1. We're not done yet. We're not done yet. Okay, not done yet. Not done yet. Not done yet. Still gotta keep going. If you want to fast forward through this, you could. Because it'll be a while. Well, maybe not. This is actually not as bad as it looks. I could have picked something way worse. Like, I don't know. If I had 4, I would probably kill myself. No, I'm kidding. 4 would just be insane. There would be a lot of things I'd be writing. A lot of things. Anyways, here we go. So here are the different ways I can arrange ba if B was first. Okay. Notice how many different. So if I have 3 things which are identical, so 3 things which are identical. So 3 things which are identical. How many different ways does it spawn, or how many identical outcomes does it spawn? It spawns 6. It spawns 6. Okay. So in this case, well, so if I had 4 unique, oh, I already did the math up there. So if I had 4 unique things, I would have 24 possibilities. But because 3 of them are identical, I have to divide by 6. Okay. Now, the other way to get 6 is by going 3 factorial. Okay. Going 3 factorial. So this will be 24 divided by this will be 4. 4 actual different ways. Okay. But how do we get 2 factorial and how do we get 3 factorial from this? Okay. It seems easy. Like with 2, it seems like, well, that's easy. I can just divide by 2. With 3, it's like, oh, wait, it's not just dividing by 3. I have to divide by 3 factorial. Will it be the same thing for 4? In actuality, it will be, but I'm not going to draw it out. So this is how I'm going to explain it to you. And hopefully it makes sense. So number of ways to arrange B, let's just do ba. Okay, so how many ways can I arrange that? Well, let's say I put B in front. Okay. How many A's do I have to pick from for the first letter after B? Well, there are 4 A's. So I have 4 A's to pick. Okay. How many A's do I have after that? I've got 3 more to pick. After that, I've got 2, and after that, I've got 1. So how many combinations will this spawn? Well, this will be, there are 24 different ways I can arrange those A's. So if I have B first, I will have 24 different outcomes if B is first. But they're all identical. So 24 identical outcomes. Identical outcomes. Okay, so for 5 objects, where 4 of them are the same, this will be as follows. It'll be 5 times 4 times 3 times 2 times 1. But I have to divide this by 4 factorial, because as I see here, I have 24 identical outcomes by arranging my 4 A's. So this would be 120 divided by 24 by 4 factorial. 4 factorials is 4 times 3 times 2 times 1, which is 24. So that'll just be 5. Okay. That's how we reconcile it. That's how we reconcile it. What if I extend it to something like this? Okay, and this might not make sense right now, but because the beauty of having this video is you can always watch it over and over again. So number of ways to arrange, let's say I have ba, and then I'll put a C, and a C there. Okay. Well, think of it like this. Let's put B first. Okay. How many ways can I arrange the A's? Well, I can pick 2 A's for the first one, and the second one I can pick 1 A. How many ways can I arrange the C? Well, there's 3 C's to pick from first, and there are 2 C's after that, and 1 C after that. So the A's give me 2 factorial identical outcomes, and the C's will give me 3 factorial identical outcomes. So for this particular case, I would do the following. There are 6 letters, so if they were all unique, I would have a total of 6 factorial outcomes. But I have to divide that by the number of outcomes which are the same, because I have 2 A's, and then divide that by the number of the same for the C's, so 3 C's. This would be, in my calculator, I do 6 factorial, clear everything, 6 factorial divided by 2 factorial divided by 3 factorial equals, my calculator tells me I've got 60 possibilities. Okay. And we can actually generalize this for any number of identical objects in my group. So, in general, number of outcomes, equals n factorial, and n is the total number of objects. Okay. And we'll divide this by a factorial, b factorial, c factorial, and so on. And a, b, and c represent identical object number of identical objects. Okay, of one type. Number of identical objects of one type. Okay, that's our general formula. So if I have multiple outcomes, or if I have in one set of objects, identical objects, then I have to divide the total number of outcomes. That's the n factorial. I have to divide that by the factorials of how many identical objects I have. Okay? And hopefully that makes sense. Okay. Let's deal with restrictions now. So restrictions. Permutations with restrictions. Okay. So a good example of this is kind of, let's take a letter, or a group of letters. Examples. So A, B, C, D, and E. Okay. Number of ways to arrange. If, let's say, A is first. A is first and E last. Okay. So these are my restrictions. Okay. So one way to visualize it is I'm going to put A first. There's only one possible way. Okay, and then I'm going to put E last. And in the middle, I'm going to stick 3 empty boxes. Okay, so this is the only way we can get A first and E last. Now, inside here, there's no restrictions. So I can put, how many letters can I put in the second spot? I can choose any of the 3 remaining. The third spot, I can choose any of the 2 remaining. And this one, I can choose any 1 remaining. Okay. So this will be, so the number of outcomes will be, well, there's 1 way to arrange the first letter. There's 3 ways to arrange the second, 2 ways to arrange that, 1 way to arrange this, and 1 way to arrange that. So this is basically just 6. There's 6 different ways to arrange this if A is first and E is last. Okay. Now B. What if I want to arrange this is, so number of ways to arrange if, let's say, B and C are together. Okay. B and C are together. So let's say I put B and C in the front. Okay. And then I'll have 3 extra spaces after that. Well, the same kind of math applies. I've got 3 possible ways to pick that letter, 2 possible ways to pick this, and 1 possible way to pick that. Okay. Now the neat thing about this is that to sort of shorten this, there's no restriction that B has to be first, so I could actually swap these 2 around. Okay, so this could easily be CB. So this tells me that the first 2 letters is actually 2 possible arrangements. Okay. In the second letter, or third letter I guess, there's 3 possible arrangements, fourth letter there's 2, and last letter there's 1. So this gives me 12. Okay, but that's if B and C is first. What if there's second? What if there's second? Well, the same kind of math exists. The first letter is then unknown, and then we have B and C, and then the second letter, or fourth letter, and then the last letter. First letter, 3 choices. Then B and C gives me, again, we can swap those 2 choices there. I'll just bring it down here. Fourth letter, 2 choices, last letter 1. So the total number of outcomes will be 3 times 2 times 2 times 1, and this will be 12. Okay. Same can be said if B and C move to the middle, or here. So if B and C are, so the first letter is unknown, second letter is unknown, and have B and C in this spot, well, same math. If B and C happen to be the last set, same kind of math. So first letter gets 3 choices, second letter gets 2. This combination gets me 2 different types, and then 1 for the last one. This will be 3 times 2 times 2 times 1, or 12. That's a terrible 12. Here this will be 3 times 2 times 1, and again there's 2 there. So 3 times 2 times 1, this will be 12. And altogether we just add those up. So we have 48 possibilities. Okay. Now what I'm really doing is I'm just using the fundamental counting principle because I've got, and I'm kind of just drawing it out. Okay. It's just ask yourself, like, in a case like this, B and C together means that they can be at the front, in the middle, sort of in the middle, and at the end. And then you see, well, in the remaining spots, how many letters can I pick? I can pick 3. Then that next spot, I can pick 2. Next spot, I can pick 1. And then we just multiply. Okay? So lots of multiplication. Lots of multiplication. Alright. I think that with that, you guys should be able to do your assignment. You just have to, don't be afraid to just draw a picture and ask yourself, how many possibilities do I have for the first? How many possibilities do I have for the second? How many possibilities do I have for the third? And just count like that. Okay. Oh, I'll do one more example with you, because this is a very common example. This is a pathway. We call these pathway examples. Okay. Number of ways to get to A, or to get to B from A by only moving up or right. Okay, and the situation will look like this. So let's say I have a box like that. I'm going to put A in the corner and B in the corner, and then I'll just draw a grid. You'll have to forgive me if my lines are not super accurate, even with the line tool. Okay, so when I say move up or right, when I move up to the next line. When I move right, I move right to the next line. Okay, there you go. So one possibility is as follows. I can go up, right, up, right, up, right, up, right, right. Or another one is maybe I'll go right first, right, then up, then right, then maybe up, and up, and up, and then right, and right, and right. Or a third possibility, maybe I'll just go right, 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 then up, 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 up. Okay, there's a lot of possibilities. Okay, but to go about this problem, you kind of ask yourself, well, how many times do I have to go up? Well, no matter what path I take, I always have to go up 1, 2, 3, 4. So I'll call that U. Okay. So I have to go up 4 times. Always have to go up 4 times. Now to the right. I have to go 1, 2, 3, 4, 5. So I have to go 5 ways to the right. Okay. And I'll call that R. Okay, so R, 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 R. Sound like a pirate. Okay. So I always have to go 5 up, or 4 up, and I always have to go 5 right. And to give you an idea, this is true, because this is 1, 2, 3, 4 up. The red path goes 4 up, and 1, 2, 3, 4, 5 right. The blue path goes 1, 2, 3, 4 up, and 1, 2, 3, 4, 5 right. The green path goes 1, 2, 3, 4, 5 right, and 4 up. So this is always true. Now you have to figure out, well, how many ways can I arrange this? Well, altogether, 1, 2, 3, 4, 5, 6, 7, 8, 9 different ways. So 9 factorial. There's a number of ways to arrange 9 objects. But we have a couple of similarities. First, how many up paths do I have? Well, I have 4 of them, so we have to divide it by 4 factorial. How many rights do I have? I have 5 identical rights, so we divide that by 5 factorial. So altogether, the number of different ways is this. So 9 factorial divided by 5 factorial divided by 4 factorial. Altogether, there are only 126 ways to go. Okay. And that, with that example, you guys should be well equipped to go and do your assignment. Good luck.